All right, so in this video, what we're going to do is we're going to bridge the gap between sort of the conversation we've been having the last couple of weeks, which has been this conversation about profit maximization, and then a lot about sort of cost minimization. Um, when a firm selects a quote unquote optimal number of a particular input, the idea is that that optimal decision, because it's based on the relative productivity of that particular input relative to its cost. So basically, the sort of conversation about profit maximization in terms of optimal input selection is our balancing, us as the firm are balancing the cost of that input with how productive it is for us, how much it enables our production of our output. If you think back to the beginning of the this particular lecture, I sort of made an allusion, something that I picked up from business school, that the production function can be thought of, as a box, and that box has a crank on it, and the inputs, in this case X1 and X2, go into the box, and then what comes out of the box is output Y. And so the choice of how much to produce, which underlies the main conversation of profit maximization, is about a firm locating the optimal number of units to produce, that being Y star. And the idea is that the firm's production function, which we can write down simply as Y is some function of X1, X2, and we can get specific with it, like we have, where it could be something like X1 alpha, X2 beta. We might have the Cobb Douglas there, and keep in mind also that alpha and beta can just be set to one, and we get just x1 times x2 as a sort of Cobb Douglas production function as well. It doesn't really matter. The production functions that we typically envision are ones that make some sense, that seem to conform to some empirical understanding of how business works. At the end of the day, of course, this is theoretical, and typically what we're interested in from the perspective of a plausible production function is that it has concavity to it. In other words, if we think about, let me get rid of this. If we think about the sort of view of the production function, in terms of say a particular input, as we've shown so far, x1 for example, and then this is y here, the production function looks something like this. And so y is a function of x1 and x2, and we typically fix one of the inputs when we frame it this way, so we can sort of just ask ourselves what happens when we vary x1, or in this case, increase x1. To what extent does it cause increases in production? And so this is again that firm capability. How is the firm able to translate its use of inputs into its overall level of production? That's sort of the main question at hand. And it's interesting because all of this is, despite being very theoretical, is easy to translate into any sort of business situation. When businesses hire someone, they are weighing the cost of that decision, which is the wage they're going to pay that person, with the extent to which hiring that individual is going to add to their production. And now when we take this out of the theoretical world, there's a lot of attributes and characteristics of someone that could contribute to production. Someone could be really good at math. Someone could be really good at structural visualizations. Someone could be a really good writer. Someone could be really good working with their hands. Someone could be very good from a physical perspective. And so there's a lot of different reasons why someone in a modern supply chain contributes to the overall profitability of a firm. But if the firm is rational, as most firms at least try to be, then the decision of, for example, whether they should hire someone is going to be about the balance between what it's going to cost to hire that person and the extent to which that person will benefit them economically. And of course, when we say benefit them economically, we mean either add to or take away from, if we're talking about non-benefiting someone's profits. There have been circumstances where someone has been hired for a position with the belief that they would contribute to the profitability of a firm, and it may turn out, in fact, that they hurt that firm's relative profitability, and that person may end up getting the axe at some point in the future. And certainly there have been people who've gotten the axe who didn't actually contribute to the lack of profitability of a firm, but it may have been blamed on them. So this idea that someone is hired and then paid a particular wage for their contribution to the ability of the firm to produce is very common and very basic. We may bemoan it in some circumstances, but even when we're thinking about sort of creativity, hiring someone because they're creative, it's what's the purpose of the creativity ultimately is to maybe either think of different ways to produce your product and in the hopes of making yourself more efficient, or designing your product in such a way that more people want to buy it, which would then give you the space to produce more and hire more people potentially, so on and so forth. So, and of course, the same thing would go with any, other type of input that isn't labor. I always, try to caution myself whenever we discuss labor in the context of firm decision making, because we are talking about humans, whereas for a lot of other inputs, raw materials, natural resources that are used in the production of some output are not human, and it's easier to talk about them as sort of optimal decisions and so on and so forth, because they're not humans. And then so when you bring the human conversation in, it gets a little stickier, which it should. It should. It's part of the conversation. So but certainly the same exact conversation goes on with respect to whether a firm wants to buy more of an input, again, in concert with their production function so as to produce output. It's all boils down to, will the purchase of this particular input, when put into our production function, when combined with the other inputs, will it add to our ability to produce? And if it does add to our ability to produce, is the resultant basically change in revenue worth the resultant change in cost? That's the basic sort of decision. And if we make the assumption that firms are profit maximizers, then the decisions that they make are going to be in an attempt towards that particular goal. And so the decisions of how much to produce in the context of profit maximization, the decisions of how much of their inputs should they use in the context of not only profit maximization, but also cost minimization, these two factors lead into another function that's going to describe, relative to particular market conditions and the internal cost of a firm, how much that firm supplies on the market. And then once we sort of get that kind of concept out of the way, then it's a pretty short hop, skip, and a jump to the conversation over market supply. So that's what we're going to do in this video, is that we're going to talk a little bit about firm supply, and then a little bit about how that translates into market supply. Now, one of the things that we have to do right off the bat is we have to immediately confront the fact that there's, in fact, two different sort of very broad market structures that we're going to consider that are sort of on the two extremes of the competition spectrum. Oops. The two ends over here, we have competition, and over here we have monopoly. And the idea is that we can think about this basically in terms of number of firms. So as the number of firms increases, we expect, theoretically speaking, for the market to become more competitive. And I say theoretically speaking, but I mean this is the expectation that we would also make in the real world. If a market went from being less competitive to more competitive, we would typically assume that occurred because more firms entered the market. That's generally the way that we think about it. And so we're going to think about in this particular video, we're going to think about the situation where markets are competitive, and then on the next class we'll talk about the monopoly situation. And again, we're going to frame this from the decisions of competitors in a market, in a competitive market, the decisions of the monopolist in a monopolistic market. We're going to frame this as the decisions being made by individuals within those markets. So in the competition conversation, this is one firm amongst many firms in a market. And then, of course, with the monopolist situation, this would be a single firm which dominates the entire market. So that's what we're going to do. So let's start with competitive markets. In competitive markets, the firms are maximizing a very basic sort of profit function. You'll see what I mean by that when we get to the monopoly profit function, because it's still a little bit more complex. And so the producer's problem, as we call it, under competition, looks like this. So we're going to sort of maximize a profit function where the choice variable is y. That is output. In other words, that the choice that the firm makes in order to maximize their profits is going to be an output decision. And that firm has costs, which are some function of output. We'll talk about specific cost functions here in just a moment. And so this is a very basic profit function that we've talked about already, right? You have total revenue here, and then, of course, you have total cost here, kind of putting things in the context of what you learned when you took this as a principles course and learned about cost structures and profit maximization there. And so, but the big thing here is P here. So I'm going to put a star here. This indicates that this is a market price. Now, that's the big assumption that we make with competitive markets. So in competitive markets, the assumption we make is that no one firm has the ability to pick prices. That basically in truly competitive markets, the price is set by the market. We refer to firms in competitive markets, in fact, as price takers. They accept the price that is set by the market. They take that particular price. Now, what this means and what makes it sort of important for our perspective is that this implies something about marginal revenue for competitive firms. So if total revenue is P times Y, and we'll go ahead and do P star here, P star times Y, draw a less wonky Y there. There we go. Then marginal revenue, which is just going to be the change in total revenue divided by the change in output, is therefore just going to be P star. In other words, like if you think about, what happens to total revenue when I increase output by 1, then the amount that total revenue is going to change is going to be P star. So if Y goes up by 1, how much does total revenue change? It changes by P star. And so this implies that the marginal revenue of a competitive firm is just going to be the market price set by the market that they're in. Now, why this is important for us, and a little bit of a spoiler alert, is because we already know what the profit maximizing decision of the firm is when we're discussing output decisions, right? So we've sort of framed profit maximization 2 different ways. We can think about it in terms of the output decision, how much should the firm produce, and then we sort of use that as a door into the conversation about optimal input selection, but still under the assumption that the optimal input selection was about producing the optimal level of output. So here we're just going to say, optimal level of output, but we're still implying underneath all of this that optimal input selection is also occurring. We're just sort of skipping that step, and we're saying that the firm is picking a profit maximizing level of output. Why? Well, we already know the rule for this, and the rule is that the firm maximizes profits when their marginal revenue is equal to marginal cost. So what this implies is that in competitive markets, we have a particular outcome of that rule, which is that because the marginal revenue for a firm is just P star, and by the way, this would imply that every firm in the competitive market charges the same price. That would also imply that every firm in a competitive market has the same level of marginal revenue. Then that level of marginal revenue that is the same, is equivalent across your firms, is that it'll be P star. So what we have also in competitive markets is that P star is equal to marginal cost. This is the rule. This is the thing to keep in mind throughout the remainder of the conversation. It's the most important thing. A firm ultimately maximizes profits in a competitive market when the market price P star is equal to their marginal cost. Okay, now why? Why is that? Well, let's tell that story. So the reason why that is because the firm in a competitive market does not see the entire market demand curve. And so if we were to construct the so we'll do so we're going to juxtapose y, which is individual level output. So we'll call that yi, with q, where q is the full market output, which is just going to be the summation of yi. So just every firm's profit maximizing level of output added up is going to be the firm supply into the market. Now, the reason why I show it this way is because the demand curve that the firm faces looks like this. So it's horizontal for some time period, and then it sort of trails off this way. And then let me add a slightly lighter color here. Okay, so this here is the market demand, and this here is firm firm I's demand. And so basically, the story here is that at the market price P star, the firm sees what is essentially a perfectly elastic demand curve. In other words, it's horizontal. So if we just look at this here, if you look at this portion of the demand curve, that's the important point here. This says that the firm essentially faces a horizontal demand curve, which you'll notice that there is no quantity demand above, right? Quantity demand is 0 up here. And then below it, when you get out past this particular point here, and the demand curve sort of trails downward here, now you have quantity demand, which is greater than 0. But there's a problem, that in order for the firm to basically produce out to this point, they would have to have an extremely large amount of production. Basically, ultimately a level of production that would be not profit maximizing for the firm. And so, in other words, what ends up happening is that individual firms in competitive markets end up operating somewhere in the horizontal portion of their demand curve. If in some sense, if they could produce enough, they could eventually become monopolists, and then they would be able to lower prices and take advantage of the fact that, there you can charge lower prices in this portion of the market demand curve, and still able to make profit. But you'll notice, of course, that in that portion of the demand curve, the price is dropping. And so the firm has to have the ability to push the price downward. And the problem is that the firm is not able to produce enough so as to capture enough market share that would enable them to have that particular power. So that's why we say in competitive markets, firms are price takers, because essentially the part of the demand curve that they see, that they experience, is again this sort of horizontal demand curve. Now, why that matters is because by facing the horizontal demand curve, it locks price in at P star. The firm is going to charge P star from a rational perspective. In other words, unless the firm is able to produce beyond, let's just say, Y, and I'm going to put X here. Oh, no, not X. Well, like X for like extreme. So unless the firm is able to produce out to YX, um, then the firm is going to stay in that left portion, the horizontal demand curve. And so essentially, what ends up happening here is that the firm doesn't have price setting power because the firm isn't able to produce enough to be able to capture the market. This is ultimately why the idea of economies of scale becomes so important in the conversation of market power, because it's firms with really large economies of scale that are able to push their production far enough out that they're able to have market power and get at that lower portion of the demand curve. But in competitive markets, we don't think that that occurs. And part of the reason why we don't think that occurs is that in competitive markets, you don't tend to have as much economies of scale. Right. So, like, making toilet paper is a production that has tons of economies of scale. So ultimately, there are not that many toilet paper manufacturers, right? Running a bodega, however, does not have very good economies of scale. And as a result, and I mean sort of, within particular neighborhoods. So as a result, you tend to have a lot of bodegas, sometimes the ones that are, one door down from each other. And so those markets tend to be a lot more competitive. Now, could those bodegas form some sort of collusive cartel potentially? They could try to do that. There is, interestingly enough, a public advocacy for bodegas, that, in a sense, gives them some level of market power, but only within the context of like regulations and stuff. They still end up competing with each other for the most part. But regardless, we're thinking about firms in that part of the demand curve when we talk about competitive markets. Now, the big thing that we want to talk about is the cost side, because ultimately we want to frame this in the context of the cost structures of the firms, the cost curves. And so we're going to sort of change the way that we've thought about costs so far. And so far we've thought about total costs in this way. We've sort of said the total cost of the firm is equal to the amount that it pays for input one plus the amount it pays for input two, which is still going on. But we're going to frame things a little bit more generally. And we're going to say that costs are a function of output and are equal to a part we'll call variable cost, which is a function of output, and then fixed cost, which we're just going to label as F. So this is variable cost, and this is fixed cost. And from that, we're going to detail what are kind of some of the more important specific costs of the firm to us. And then we're going to graph those general functions as we expect to see them. And so let me just move this over here a little bit. And so the sort of from in terms of how we're going to visualize them, and then how, in turn, they're going to help us understand not only the decision making of the firm, but also the outcome of the decisions being made by the firm. We have what we call average total cost, which is just total cost divided by output. Oops. We have average variable cost, which is just variable cost divided by output. And we have marginal cost. And marginal cost is the change in total cost divided by the change in output. Now, you'll notice that I did not mention average fixed cost. Average fixed cost is not really that important. It ends up not factoring very much into the overall analysis, so we can sort of leave it to the side, which helps us visually because it ends up being one less curve in the framework that we're going to sort of utilize. And so that framework looks like this. And so we have output here. We're just going to put dollar here, represent money. And so average total cost typically looks like this. Average variable cost looks like this. And marginal cost looks like that. And the reason why we visualize things this way is, first off, to illustrate that the idea that um, costs for the firm are restrictive. You'll notice that when we get to these portions of the total cost curve and the variable cost curve, that it starts to really ramp up. And we expect that to keep ramping up. So, in other words, one of the constraints that a firm faces is that in order for them to produce more, they have to pay more. And that, of course, constrains their ability to produce more. And so it's nice to see that visually, to remind ourselves that this is not a story of firms just producing as much as possible, that this is a story of firms finding the optimal level of production and then choosing to produce that level. Now, what we're going to sort of do is we're just going to plop the marginal revenue curve onto this particular curve, reminding ourselves that what is the marginal revenue curve? Well, the marginal revenue curve is just the market price. And so we can put that here. So this will be P star. We can also label it marginal revenue. And this enables us to visualize the profit maximizing decision of the firm, which is going to be where marginal revenue equals marginal cost. So this is Y star. And, and so there we visually see where that occurs. And then, of course, the other thing that we're able to do here is we're able to show what profits are. The reason why we're able to show what profits are is because we have average total cost. And because we have average total cost, we actually know what total cost is at this particular point. So if we just take this over here, we'll call this ATC star. That's the average total cost at the profit maximizing level of output. Because if we just look at this particular function here, average total cost, if we were to say solve this for cost, notice that this would just involve us moving the y over. And so total cost is just average total cost um, times output. And so if we know what the average total cost is, then we can easily find out what total cost is by just taking ATC and multiplying it by Y star. That gives us total cost. And so what that means is that the total cost for this firm is illustrated by this rectangle here, ATC times Y. So it's just this nice rectangle right here. Now, total revenue, if you'll recall, is just P times Y. And so let me illustrate that. here with the blue. And so I'm going to draw the blue in here. So total revenue is here. So it's that sort of bigger rectangle. And then the difference between those two is going to be profits, which I'll label as green for obvious reasons. And so those are profits. Just total revenue minus total cost, where total revenue is just P star times Y star, and total cost is just ATC times Y star. So just the areas of those two rectangles. That's sort of the easiest way to think about it. And so that's the profits of the firm. And what this enables us to see is visually, again, the profit maximizing decision of the firm, and then also the outcome of that profit maximizing decision of the firm. It's also important to point out here, by the way, that we don't just have the firm's characteristics in this particular analysis. Because we have P star here, which comes from the market, we have an exogenous factor, the market set price, and then we also, of course, have the endogenous factors of the total cost. And so in this particular analysis, we not only see the firm's own cost structure, but we see in the way in which that cost structure interacts with the broader market conditions. We also could see that if the market price were higher, the firm would produce more, and if the market price were lower, the firm would produce less. Now, what that means and implies, very importantly for us, is that the marginal cost curve ends up taking on particular significance. So I'm just going to highlight the marginal cost curve here. In essence, because the marginal cost curve ends up being the curve where we determine profit maximizing output relative to a particular market price, then that implies that the marginal cost curve is, in fact, the firm's supply curve. So, in other words, if you think back to what a supply curve is, a supply curve says at a particular price, this level of the product is going to be supplied by a firm. Well, that's what the marginal cost curve tells us for competitive firms, right? So, for competitive firms, their marginal cost curve ends up simply being their supply curve. So individual competitive firm supply curves are simply the marginal cost curves of those firms. Okay. Now, let me show you this in a little bit of a less sort of convoluted way. So we have firm level output here. We have average total cost, average variable cost, and then marginal cost. Now, importantly, marginal cost intersects the average total cost at their naders. What we mean by naders is their minimum point. In other words, the marginal cost curve always intersects the average total cost and average variable cost curves at their minimums. Always. Okay, always. And that's just due to the mathematics. Think about the average quiz score you have versus the quiz score you get on the next quiz. Right, that's the marginal quiz score. Think about it in terms of the average quiz score, and you'll very quickly get to how this works. So the marginal cost curve intersects the average variable cost and average total cost curves at their naders, at their minimums. Okay, that's important because these points also represent, so this is the break-even point. Break-even is profits are equal to 0, and this is the shutdown point when profits are less than 0 and firm exits. Now, what I mean by that is that there is some portion here of the marginal cost curve, which again also is just the supply curve, where the firm's profits are less than zero, but they don't exit the market. They stay in the market. And the reason why that is that at this shutdown, the firm is no longer covering their fixed costs. Now, what do we mean by that? What we mean is that you're going to have market prices. So there could be a market price. There could be, draw that. There could be a market price, and there could be a market price. So P1, P2, P3. First off, you should notice that as market price declines, the firm would naturally choose to produce less. So Y1, Y2, and then here, Y is actually just zero. Because again, the firm is going to shut down. The firm is actually not going to produce beyond that. And so as the market price falls, the amount the firm produces declines until the market price can fall so much that the firm actually decides to exit the market. At P3, what's going on is firm is not covering their fixed cost. And because they're no longer covering their fixed cost, it's actually more profitable to shut down and pay fixed costs, right? Because if you don't produce anything, you still have to pay your fixed costs, right? So cost as a function of y are variable cost plus fixed cost. If you produce zero, you have no variable cost, but you still have to pay F. And so if producing and selling your good at a price would mean that you lose more money than negative F, which would be the money you lose if you produce nothing, you get to pay F. So your profits will be negative F. And so if Y is zero, profits are equal to negative F. So when Y is equal to zero, profits are negative F. And so if your profits be worse than negative F, you should just shut down and earn negative F profits. And that's exactly what goes on here. So if the market price falls below the minimum of a firm's average variable cost, it means they're no longer covering their fixed cost and they should shut down. But in the short run, the firm is going to continue to produce as long as the market price is above the minimum of average variable cost. That's the sort of stay open, shut down rules of a competitive firm. Now, why are we thinking about this in the context of a firm shutting down versus staying in the market? Why is that the conversation? Well, that's the conversation because ultimately it's simply the number of firms in the market that defines the level of production. Because what defines the level of production is going to be essentially the same across all of these firms. These are competitive firms. They're going to be very similar to their competitors. And so, in other words, they're going to end up producing generally a similar amount of the product. And so, whatever the market price is, it's triggering a production decision that is functionally the same across all firms, especially when we move into the long run. And by the way, all that happens when we move into the long run is we lose the average variable cost curve because in the long run, everything becomes variable cost. And everything that I'm saying about the firm either choosing to get in, enter, exit a market holds true for the minimum of average variable cost. It's just in the long run, average total cost is average variable cost. And so the break even and shutdown points become the same. And we get this really interesting zero profit condition under competitive market conditions, which you learned about in principles of economics. But of course, what we're interested in is how this decision-making process of competitive firms ultimately translates into the supply that we see in the entire market. So in other words, how do we go from individual supply decisions into market supply decisions? And it's just like demand. Theoretically, the way that we think about this is that we have all these marginal cost curves, they look like that for firms. And again, these are just the supply curves for those firms. Now, to sort of drive home the point that these are the supply curves, think about what a supply curve is. It says for a particular price, P star, how much does the firm produce? Well, what was the decision when we talked about profit maximization? It was to produce where marginal revenue equals marginal cost. Well, just remember that in these markets, marginal revenue is P star. And so when we say marginal revenue equals marginal cost, that's all we're saying. So we have Y1, Y2, Y3. And then all this is going to mean is that there's going to be some market supply curve here, which I'm going to label with the big S, where this Q, we'll call it Q star, is equal to Y1 plus Y2 plus Y3. Or like we drew it before, more generally, we can just say the summation, we can just say the summation of yi. So that's how we get in a competitive market from individual supply curves into the market supply curves, is that each of the individual supply curves are just the marginal cost curves of individual firms. And then we just horizontally sum them to get the market supply curve. It's really as simple as that. So that's how we get from the profit maximization, MR equals MC, which produces optimal output for each firm relative to particular market prices. And that's how we envision the market supply curve in the competitive market, is that the supply curve ultimately is just all of the marginal cost curves in the market added up horizontally. And so at a particular market price P star, we get a particular level of supply in that market. Let me put a QS here so we know that that's quantity supplied. So that's how we get from profit maximization, cost minimization to the market supply curve. So the market supply curve is simply a function of a bunch of profit maximization going on. That's ultimately why we end up thinking about the supply curve as being an efficient supply curve, because it springs forth from what we believe to be efficient economic decisions being made by individual producers. Now, there's a couple more sort of mathematical facts about cost curves that we'll talk a little bit in the next video. And then again, in the next video, we're also going to talk about how we think about this in terms of the monopolist as opposed to the competitor, and how that then affects market supply. And then that allows us to have a conversation about, well, what about those markets in the middle that are between the two extremes of competitive markets and monopolistic markets. But to drive home the point of the supposed efficiency of competitive markets, the big sort of takeaway of competitive markets is that we get that P star is equal to marginal cost. We get marginal cost pricing, is what we call, and that's what we see here. And so that efficiency of marginal cost pricing comes from the fact that in our competitive firm, their ability to set prices is restricted. They're not able to set prices, mainly because they're not able to produce enough in order to capture the market. And so what we have is a bunch of small firms who are each profit maximizing relative to the market price. And the result of that is a supply curve which reflects, once again, marginal cost pricing. Now, If market price were to rise, right? To P, same situation, right? Each firm responds by producing more, and the market was going to respond by producing more. And the same thing, of course, if market prices fall. So it's the same story. It's just whether we think about it in terms of individual firms or whether we think about it in terms of the supply. Now, this is a short run view. The reason why I know it's the short run is because I have different levels of marginal cost. The idea is that in competitive markets, there's so many firms that over the long run, the firms all end up exhibiting the exact same marginal cost. And so, what you end up having, instead of having three distinct marginal cost curves in the long run, what you end up having is just one marginal cost curve that represents all the firms in the market. And then you just take that marginal cost curve and you multiply it by the number of firms in the market. And that's going to give you the resultant supply curve. What that also means as well is that the supply curve, whether we're thinking about this in terms of the long run or the short run, essentially ends up equaling the marginal cost of producing that good to society. So if we think about all the different firms in a market as representing societal production of a product, then the supply curve represents societal marginal cost for producing that product, which understandably comes from all the individual firm marginal costs. So societal marginal cost is just the summation of individual firm marginal cost, which allows us to think about the supply curve. Even though it represents a lot of firms, we can think about the supply curve as representing the supply of the good for society coming from a lot of different firms.